Hi, hey folks, welcome to the today's daily Leetcode problem. So today is day 4 and it's 4th day of October. Today's problem is container with most water. I probably have solved this question before, yeah, I think yes. So let's directly jump into the problem. Have I solved it before? Yeah, in 2021 I have solved it. So let's try to understand the problem first and then we will try to solve it. You are given an integer array height of length n. So the n vertices you can okay. So we want to find the container with the return the maximum amount of water a container can store. Okay, something like rain trap, uh, like trapping rainwater problem, which we have solved yesterday. Okay, but here the twist is that we have to find a container which can hold the maximum amount of water, and then we have to return that how much water we can keep in that container. That's the case. We don't want the total how much water is trapped. We don't want that. Okay, so let's understand from this example number 1. Let me illustrate with diagram. Yeah. So from this example number 1, you can see that we have given some heights. So you can understand these heights are like something like pole heights. We have some poles here. So the 1 height pole, then 8 height pole, then 6 height pole. Some poles are there. 7 height pole. So at each location I, we have that much of wall. Okay, this is a wall basically. In trapping rainwater, we have understood the concept of wall. We can hold the water if we have seen the left wall and we have seen the right wall, and we take the minimum of both of them, that whichever is the minimum, and the current location, sorry, current height x. So we find that how much water is trapped on top of x is minimum of left comma right and minus height of x, something like that. Okay, so there is not that concept of like we have to trap water on top of this wall. Okay, there is a concept of that if there is two walls, we can trap water full width of water, like this full container is full, and we don't have to consider and minus these heights of these poles or these walls, right? So let's for this example, uh, right, we have a right wall which has a height of 7, we have a left wall which has a height of 8, so obviously minimum of 7, so 7, and this distance is between these two walls is 7 unit, so therefore 7 cross 7, we have a 49 unit of water trapped in this container, which is the largest. So there is one more container, that is this small container. If you see, let me change the color of here. Okay, if you see, there is one more container here which can hold 1 unit of water, but we are not considering this because we have seen this bigger container. There is two containers basically, small container, bigger container, and you can draw multiple containers here. Like you can say that this is the container between these two walls, this is a container, but it holds only 1 cross, how much the height is 2, so 1 cross 2 units of water this can hold. Okay, this is another container. If you see, this is another container, its height is 5, its height is 6, and it can hold 5 cross 2, so 10 unit of water it can hold only. This can hold 10 unit of water. So we want to find the maximum, like biggest container which can hold maximum water. So to solve this, we will take the same approach as the 2 pointer, and we will keep track of like what's the maximum wall we have seen from the left, maximum wall we have seen from the right, similar to trapping rainwater problem, and we can calculate based on that. Okay, so like I will try run on this first example. So let's say we have kept the left pointer here, we have kept the right pointer here. Okay, so what's the minimum? Minimum is 1, right? So how much water we can trap? 1 cross this complete, just a minute, 1 cross this is complete container. Okay, so what's the distance between both of the point, r minus l? Okay, and how much water we can store? Multiply by minimum of height of l minus comma height of r. So we take minimum of both of them and multiply by the distance between r and l. This is the water trapped. Okay, this is the container and we can store that much of water. So here I clearly say that l is small, so we will increase the l. That's how, because each time I am increasing the l or decreasing the r, what will happen, this size will reduce, right? Size will reduce by 1, and we will find the maximum when we will increase this. And how to increase this? By increasing the minimum value. If h of l is minimum, then we will increase this, and if h of r is minimum, we will increase this. So in this case, h of l is minimum, which is limiting us, so we will increase the l pointer here, left pointer here, so our height will increase and we will find this container. Okay, in that, after this case, that ir pointer will be smaller one, so we hope to find like bigger container by reducing the width. So we will move r pointer to here, and we find that it's smaller, then we will move r pointer to here, we calculate this container and how much water this trapped, something like that, and we calculate in each and every step, and we will take a running maximum sum, running max, which will hold how much water we have trapped till now. So let's code it directly, so you will clearly understand after that. Let me remove the drawings. So simply we will take that how much the height of the length of the array. Okay, and we will code that if n is less than 2, then we will return 0, that there is no two walls, between them we can trap some water, there is no container to form. And we will now keep two pointers, low point l pointer, left pointer, which is at 0, and right pointer, which is at n minus 1. Okay, and I will do a while loop, l less than r, till l, because we will be increasing l, we will be decreasing r. We will keep l less than r, and we will not keep equal, because if l and r equal, then we can't trap any water and there is no container to form. So let me define a variable answer as well, which is like answer trapped, like water trapped equal to 0. Okay, so we will check that which of the wall is smaller, we will move that. Okay, but before that, let's calculate how much water is trapped with this current r and current r. Okay, so water trapped is equal to maximum of water trapped comma. Okay, so int current water trapped equal to how much is this, r minus l length multiply by minimum of height of l comma height of r, which we have discussed, comma height of r. This is the current water we have trapped in current container, and we will mix both of them. And if height of l is less than equal to height of r, somewhere we have to keep equal, so you can keep equal condition in if condition, if block or else block, doesn't matter much. Height of r we will do l plus plus, else we will do r minus minus. Fairly easy and simple. We will return water trapped here, and let's run this solution. Yeah, both the test cases is accepted. Let's submit this. Yeah, so this solution is accepted. The brute force approach for this problem will be like, we will be doing n square solution, where we will keep like running I comma j in each and every location, and we will find how much water is trapped, so that will be n square. So by this two pointer approach we have solved this problem in basically of only we have traversed the array once. Okay, so we have solved in time complexity of n, and space complexity will be of 1, because we aren't storing any array or something like that, like auxiliary space, nothing. We are just looping it. We have defined some variables which is o1. Hope you find this solution interesting. Let's meet tomorrow. Bye.